The topic of this video is general chemical reactions and stoichiometry. In general, there are two different notations used to describe the way a chemical reaction occurs. In this video, we will be discussing the unidirectional arrow, which designates a complete chemical reaction. So in this example, chemical A reacts with chemical B in a complete fashion that exhausts the reactants A and B to produce the products chemical C and chemical D. In a separate video, we will cover the use of bidirectional arrows, which designate a forward and reverse reaction where incomplete dissociation or incomplete reactions occur. In these situations, the reactants A plus B react and produce products C and D in an incomplete fashion, and simultaneously the products C and D revert to the reactants A and B. Again, this will be covered in a separate video. Now let's use a real-world example of a complete reaction. We will use the dissociation of the salt magnesium chloride in water. So as I've mentioned previously, this unidirectional arrow designates that this reaction occurs completely. So when magnesium chloride, the salt, solid, is placed in water, magnesium ions completely dissociate from chloride ions, and we are left with one magnesium ion and two chloride ions. Another reaction is the decomposition of calcium carbonate. When heated, calcium carbonate will produce calcium oxide and carbon dioxide, again in a complete fashion. Another chemical reaction that occurs completely under the right circumstances is the combustion of methane. When methane is combined with oxygen, again in a combustion reaction, the products are carbon dioxide and water. And again, under the right circumstances, this reaction occurs completely so that all reactants react and produce products. There are no reactants left over in this situation. Next, let's use stoichiometry, which is the relationship between the relative quantities of substances taking part in a reaction or forming a compound to determine how many moles of reactants will produce how many moles of products. And again, this can be used in a balanced chemical equation where we have the same amount of atoms of each element on the reactant side as well as the product side. So here, in our first example, the complete dissociation of magnesium chloride, we know for every 1 mole of magnesium chloride, the 1 would be here, we produce 1 mole of magnesium ions, again a 1 would be here, and 2 moles of chloride ions, designated by the 2 here. What this means is that the stoichiometric ratio for this chemical reaction is 1 mole magnesium chloride to 1 mole magnesium ions and 2 moles of chloride ions. In our next example, the decomposition of calcium carbonate, we know for every 1 mole of calcium carbonate that we start with, we produce 1 mole of calcium oxide and 1 mole of carbon dioxide. Again, there would be a 1 here, a 1 here, and a 1 here. So we know the stoichiometric ratio for this chemical reaction is 1 to 1 to 1. If we began with 2 moles of calcium carbonate and did a complete decomposition reaction, we would produce 2 moles of calcium oxide and 2 moles of carbon dioxide. Again, the ratio stays at 1 to 1 to 1. In our last example here, the combustion of methane, we know that for every 1 mole of methane, again there would be a 1 here, that reacts with 2 moles of oxygen gas, again denoted by the 2 here, will yield 1 mole of carbon dioxide and 2 moles of water. So the stoichiometric ratio for this chemical reaction is 1 mole methane that reacts with 2 moles of oxygen will produce 1 mole of carbon dioxide and 2 moles of water. Otherwise, also stated as 1 to 2 to 1 to 2. Now let's demonstrate the true power of stoichiometric chemical reaction ratios by combining them with dimensional analysis. So we can use these two principles combined to answer the question, how many grams of chloride ions are in solution when 34 grams of magnesium chloride are dissolved in water? By using our balanced chemical equation here, where the solid magnesium chloride dissociates in water to produce 1 magnesium ion and 2 chloride ions, we can use this to answer the question above. So we know for every 1 mole of magnesium chloride placed into water, we will produce 1 mole of magnesium ions and 2 moles of chloride ions, using our balanced chemical equation and the stoichiometric ratios between products and reactants. So the ratio for this is a 1 to 1 to 2. As with any other complex chemical question, using dimensional analysis, let's begin with the information we have. So we are asked how many grams of chloride ions are present after 34 grams of magnesium chloride dissolve in water. So let's begin with 34 grams magnesium chloride. We know that we have to convert grams magnesium chloride to moles magnesium chloride because ultimately the stoichiometric ratio comparisons used here are in moles. So this relates 1 mole magnesium chloride to 2 moles chloride ions. So let's begin by converting grams magnesium chloride to moles magnesium chloride. We can use the molecular mass of magnesium chloride over here, which is described as 95.2 grams per every 1 mole. We know that because this conversion factor can become interchanged, 1 mole of magnesium chloride is equivalent to 95.2 grams magnesium chloride. So if we place this over here and multiply our values together, we cancel out grams magnesium chloride, and now we have moles magnesium chloride, which we can use to directly compare the number of moles of chloride ion produced in this chemical equation. So if we place this in, we know for every 1 mole of magnesium chloride we start with, 2 moles of chloride ions are produced, so 2 to 1. Multiply these together, our units cancel out. Now we have moles chloride ion. Our last step, because the question requires us to answer in grams of chloride, is to convert moles chloride to grams chloride. So we can use the molecular mass of chloride ion, described over here as 1 to 34.45, and again, because we know these are interchangeable, we can describe this as 35.45 grams chloride to 1 mole chloride. When we multiply these together, moles chloride cancel out, and we're left with grams chloride.